Welcome to our new lesson. This lesson is going to be, once again, dealing with absolute values. We're going to be focusing on graphs, specifically inequalities. So let's get started. What we're going to do first is we're going to utilize Desmos. And let me do a home screen here. All right, back to the home screen. So on the Desmos graph, what you need to do, this is going to be question number 1 in your assignment, is we need to graph the following two inequality functions. So we're going to create a system of inequalities. So f of x is less than or equal to a negative absolute value of x minus 3 plus 6. And let's move those to side by side so we can see them both together. So the way we write it, we'll do our f of x. And to get a less than or equal to, you can either go down to here and type in and hit it, or you can manually do shift the comma and then just hit equal to get that bar underneath. You do the negative absolute value, x minus 3. Hopefully you're good at typing in an absolute value now, plus 6. And that will be our inequality. Well, it's not letting me like the f of x. Let's try y. All right, much better. All right, don't use f of x, use y. All right, for the next one, we'll do y is greater than, parentheses, x minus 5 squared plus 2. And you'll notice that there's shading. Anything less than or equal to is going to be shaded below it. Anything greater than is going to be shaded above it. Notice the different styles of the lines. The less than or equal to, that's going to be a solid line because it includes that, whereas the greater than will be a dashed line. If you took the equal sign off here, it would also be dashed. And of course, if you added an equals here, it would be solid. So that's the difference between those two. Now, what you're going to look for on an answer the actual solution is not all of the stuff that's color. The actual solution is the part that's combined. So we don't need those two parts. This part right here, that's your actual solution to this inequality. So when you look for your answers, your graphs, you're going to pick the one that has just the overlap part. So look for the overlap. And to recap, dashed line is the less than or greater than, solid line is the less than or equal to or greater than or equal to. So hopefully that's pretty straightforward. Now let's talk about how to solve inequalities. We're going to start with the less than or equal to inequalities. Okay, the first type of inequality you're going to encounter is one such where you could have an ideal situation where you might have a scale and it might be off by a few pounds. So in this scenario, in this case, this is example 2. You step on a scale and you weigh 180 pounds, but the scale could be off by as much as 7 pounds. So you don't really know if you're 7 pounds above it or below it, and you're asked to write an absolute value inequality. So the way that those work is you write the absolute value of some variable. We'll call all our variables x, but you can call it w for weight if you want. But you know, weight is going to be your x variable. And I should say your true weight. Okay, because you don't really know if you're 180 or somewhere 7 higher or 7 lower than that. So that x would be your true weight. Now you're going to subtract from your true weight what the scale is going to be reported. So that 180, that's going to be your reported. Now you're going to find out in a minute why it goes in the absolute value inequality, but your true weight, we don't know that yet, is what you start with, and then your reported is what you're going to end with, okay? Now that difference can be no more than 7. So since it says the scale could be off by as much as 7 pounds, you say less than or equal to 7. Now let's think about why that is the answer. Let's say you're 187 pounds, right? Let's check this. Well, if I'm 187 pounds, actually, well, that's the absolute value of 7. And that checks, right? If I plug in 188 there, that's going to be 8. And that's going to be, it's not going to be less than or equal to 7, so it's not going to work. But let's look on the low end. Let's say you're below 180. Let's say you're 173. Well, that is the absolute value of -7, which is still 7, right? So that's still going to be less than or equal to 7. So anything between 173 and 187 is going to give you answers that are within that acceptable range. So your inequality will be absolute value of x minus 180 is less than or equal to 7. All right. So now let's talk about the next steps for that. That's your inequality. That's your reported. And then you have your true weight, and then this is going to be how much it's off by. Let me circle that answer. Now, let's look at another part of it. It says, what is an acceptable range of weights, or range of values for your weight? Well, we already have the answer to the inequality, right? We got the absolute value of x minus 180, which is less than or equal to 7. Now, we can solve that to get the acceptable range of weights, but we don't really need to solve it because it's really off, we're off by as much as 7 pounds. So it's anywhere between 180 minus 7 and 180 plus 7, okay? So that's going to be, between 173 and 187 pounds. But we don't want to write it like this. We want to write it as a math statement. So we say 173 is less than or equal to x, which is less than or equal to 187. Okay, so that is how you get just the acceptable range of weights. This is the inequality. In the next example, I'm going to show you how to solve that inequality, some more complicated ones, to get your acceptable range of weights, okay? But first, we got to set up the inequality, and it's going to look a little bit different. So take a minute to read through this example. A refrigerator's temp can be anywhere between 34 degrees Fahrenheit and 40 degrees Fahrenheit for the food to stay fresh. Write an absolute value inequality to represent this scenario. All right, think about that for a minute. What you're given is the acceptable range of temperatures. This time we want to go work the other way and get the inequality. So I'm going to go back to first the previous example, and I want to show you something on Desmos, okay? So I know I'm kind of backtracking here, but go to Desmos, clear out what you got, and I want to show you something here. In fact, I'll just leave Desmos open so we can compare our work here. So if you take this inequality that we wrote, the absolute value of x minus 180 is less or equal to 7. You can type that into your Desmos line, the whole thing as is. So type it in like this: absolute value of 180 less than, and then hit the equal sign to put the bar there, 7. Now notice what happens. It gives you like this little shaded thing with the dash. You got to pull it over because it's you know, goodness, it's 180, so you're gonna go a little bit further to the right, but, or you can zoom out if you want. But I want you to look over here. It's gonna give you a shaded boundary, and you know, if you zoom in enough, you can kind of tell it's gonna be between that 173 and that 187. And notice those are both dashed lines because it's got the equal, and it could be, or solid lines because it was equal, but it could very well be dashed lines if you took the equal out. So look at the difference there. Now, let's look at this example in this context here, okay? We want to try to find an absolute value inequality that's going to give me a shaded boundary between 34 and 40 degrees Fahrenheit. So what we're looking for is something like this. So we have to figure out what's going to be halfway between 34 and 40. Okay, that's that number that's going to go in the absolute value. And that's usually like that's the ideal temperature, right? So we can get that by just taking the average of the two numbers. So find the midpoint of 34 and 40. Well, you can probably guess what it is, but you can also just add them together and divide by 2. Well, it's going to be 74 divided by 2. Or you can get all fancy and type it in here, but that's 37. 37 is halfway between 34 and 40. So the significance of 37 now is that's going to be the number that goes inside the absolute value. You do x minus 37. You do less than or equal to. Now, what is the other number that it's going to be? So I want you to think about a number line or something. All right, you got a number line here. You got 34 down here. That's your low end. You got 40 up here. That's your high end. And you got your middle number. We got to figure out that the tolerance. In other words, how far above or below we can go. And that tolerance is how much you can be off by. So we could be off by, in this case, 3 in either direction. You know, 3 above it or 3 below it. So that number, that's the number that's going to go down over here. That's your inequality. Let's graph this. You can press the home button, go back to your home screen, clear that out, and we're going to type absolute value of x minus 37 is less than or equal to 3. And we're going to zoom to find it. And let's just make sure we're on the right track, okay? Your shaded weights are between 34 and 40, so we're good, all right? We've accounted for that with our inequality. So your goal, can't stress this enough, your goal is to write the inequality. Sometimes they give you that middle number right there, and they tell you how much it is off by, and those are the numbers. The middle number, if they give it to you, and the wiggle room, if they give that to you, those go in those spots. But if they don't, if they give you the low and the high end, then you got to get the middle number by averaging those two, and then figure out how far away from the low or high end it is to get that number there, okay? And one more problem I want to do with this type of inequalities. So with this example, you know, we do have to know how to solve these by hand, but they're going to be a little bit similar in terms of like what we're looking for. We're looking for a shaded region between two numbers when it's a less than, okay? So we still have to isolate the absolute value. So that means we have to get rid of everything that's surrounding that absolute value. So in this case, it's going to start with this 3. We're going to divide the 3 out, and then we're going to be left with that x absolute value of x minus 5. is less than or equal to 4. Now, to actually solve this without using a graph, what I do is I write like a sandwich inequality, okay? I take one of the numbers on the right side and I make it negative. And then I do a less than or equal to. Basically, I just copy that. So if it said less than, I'd copy a less than. I write x minus 5, and then I say less than or equal to 4. So I throw a negative over here, and I keep that there and get rid of the absolute value inequality. Now that's going to become basically an answer with a low and a high end. For all of these, to get rid of that minus 5, I'm going to need to add 5. So that's going to give me negative 4 plus 5, which is 1. This is going to be 4 plus 5, which is 9. And of course, this is just going to be x in there. So my answer, it lies in x being between 1 and 9, including both 1 and 9 because of the equal sign. So that's actually the answer. Okay, x is greater than or equal to 1, but less than or equal to 9. Now you're also going to have to graph this. So on a number line, you would write, in this case, 2 closed circles, and they're closed because of the equal sign. They would be open if they were if that equal sign was not there. Put the lowest number there, highest number there, and you're going to shade in between. So all numbers between 1 and 9 would be acceptable answers for that graph. Now let's go back and put the original graph in Desmos. Pause the video for a second and type 3 absolute value of x minus 5 is less than or equal to 12, all into the line in Desmos. Great, hopefully you got a chance to do that. Again, what we're looking for is that acceptable range, okay, between two numbers. So we're gonna have to kind of hunt for it, but in this case, we have found it. We got our low end, 1, and that's a solid line because of this equal. And our high end, 9, and that's also a solid line. And that matches up with our number line here that we just drew. We don't actually have to draw the graph in 2 dimensions. We just draw a 1-dimensional number line to represent the range of values that is acceptable here. All right. Now, what happens when we reverse it? Okay, let's talk about greater than or equal to. It's going to be a little bit different. So let me show you by hand how to do these. And this should be example 5. So let me fix that now before I mess everybody up later. And then let's do example 5. Let's call that 6. I'm kind of editing this as I go. So, all right, 2 more examples. So example 5, it's the same problem, okay? But notice that it's now greater than. So what we want to do here is we want to follow the same steps to isolate. Absolute value of x minus 5 is now greater than 4. And we also want to list out a negative and a positive. But you see that little inequalities pointing this way, right? So we're going to put a negative. We're going to keep it in this direction. Just do x minus 5 and then write 4. So when you're solving that, it's you're going to add the 5 to both sides. So we'll add it to the 4 and the negative 4. And that's going to give you positive 1 in this case, greater than or equal to x. Now, we can't really do greater than, it doesn't work to put the x in a sandwich this way. So we just separate it and we say or, and then we write the x again. X is greater than 9. So we have to copy the x twice in these problems. And I don't like saying a number is greater than x, so I'm going to flip this or reverse it. And I'm going to say x is less than 1. So basically move the x over here, the one over there, and switch the direction. Now let's conceptually think about what that means. And again, I'm going to show you on a graph what we're talking about, okay? So if we look at this graph that we did here, if I change it to greater than, it's the same boundary lines, right? This one's dashed because it's not equal to, but it's the same boundary lines, but it's going outside as opposed to connecting them. So that's why you're seeing x is less than the smaller one and x is greater than the larger one, because they're not connecting, right? They're disjointed, they're separate. So so on a number line, this would look like arrows pointing in opposite directions. And also, because I don't have equals under these, it's going to be an open circle. So if I got a 1 and 9 there, my solutions would be anything less than 1 and anything greater than 9. I want you to think about, like, if you plug in numbers, right? If I said 3 absolute value and I took a number greater than 1, so let's say I did 3 minus 5. That's going to give me 6. That's not greater than 12. But if I plugged in 1, that's going to give me 12. It's not greater than 12, so 1 doesn't work. But if I throw in 0, that's going to give me 15. That's bigger than 12. The same thing if I go in the high end. If I put a 9, that's going to give me 12. We don't want to equal in this case. But if I put a 10, that's 15. 11, 15, 18. So any of the numbers outside of the numbers between 1 and 9 work in this case. That's where the number line plays in. So let me circle the answers first so we can get that. So this is going to be your answer. And just one more. I'd like you to try this. This is the last one on here on the video. See if you can solve that and solve it in graph and use Desmos to assist if you need to. This one's a little trickier because it's got fractions or decimals depending on how you write your answer. All right, hope you got a chance to pause it and check your answer. We're going to just double check this real quick. Your goal always and forever is, of course, I'm going to change this again. It's not going to change your answer, but this is the way it's going to look like on your assignment, okay? So when you're solving this here, you're going to add the 4 to both sides, get rid of that minus 4. That's going to give you 18, so we're back to where we were already. And then we got to divide by the number in front of the absolute value. So 18 divided by 2, that's going to be 9. Now, we're still going to follow that same kind of pattern we did before. So if you remember on the other one, we wrote out kind of the negative, the stuff in the absolute value, and then the negative stuff in the absolute value and positive, and then we did the greater than symbol. So let's do the same thing here. It's going to be -9 greater than or equal to, because it's got a line under it, 3x plus 7 greater than or equal to +9. And we got to solve these, so we're going to subtract the 7 from all sides. And that's going to be -9 minus 7, which is -16, greater than or equal to 3x, greater than or equal to 2. And then finally, we want to divide by 3. So notice that you got a fraction on here. So it's going to be -16 greater than or equal to x. Now remember, I like to split that. So then we say, or x is greater than or equal to 2/3. And I said 16, but I really should have put that over 3. You can give me a decimal for those if you want, but I can't reduce those fractions. But remember, I don't like it like this. So we're going to flip it, and we're going to say x is less than or equal to negative 16 over 3, or x is greater than or equal to 2/3. Okay, that's your answer. And on a number line, it would look like closed circles because these are equal. Put your smaller number over here and shade away from each other since it's got the greater than here. So now let's graph it. Let's back it up with Desmos. Everybody should be graphing all of these in Desmos to verify what they look like. So I'm going to start with the original equation. Always go back to what you started with. 2 absolute value 3x plus 7, close absolute value minus 4 is greater than, shift greater, equal 14. And if you notice it, it's shading in opposite directions. So we got the shaded part on the number line correct. This number is a little bit harder to get, right? If you go over here, you can zoom in a lot. And you might say like negative 5.34, but what is that decimal exactly? Well, that's where the solving by hand might help, okay? If you did negative 16 divided by 3, it's negative 5 1/3, so that's what that number is. And then if you go over here and do the other side, that's 0.65666. 6 repeating is going to be, and that's going to be 2/3. Okay, so that does match up with the numbers here on the graph, but sometimes you'll have to come up with those numbers by hand. You can also get them by intersections, but I'm not going to go that route today. So you can look on yesterday's lesson if you need help with that. All right, so I'm going to stop this lesson. Hopefully that's enough for you to understand what's going on. And you have good luck with your assignment. Reach out to your teacher if you have any questions. Peace. Have a good night.